I think that consensuslessness or whatever we want to call it is a very big deal. I think that we're going to see a lot of systems that do this. Something we haven't really touched on is that Delta can scale fully horizontally. It can scale, okay, execution, that's not so interesting. You can add more domains. Okay. But in this case, because you have this leaderless, parallelizable consensus or consensusless, whatever you want to call it, right? Which doesn't have the linearizing bottleneck of the blocks. You can run mempools in parallel. Validators can add machine. They can kind of arbitrarily add bandwidth in a way that you cannot if you have traditional consensus. It's just impossible. It makes for more robust, more decentralized, because you don't have a leader dependency. So a more decentralized, base layer protocol, more lightweight and parallelizable. I think it's a huge deal.
Hey everyone, this episode is brought to you by Supra, the vertically integrated L1 for super dApps. They have a very cool new product coming out called Supra Containers. So head over to supra.com. That's supra.com/containers. So if you're building on an L1 and it feels a little bit crowded, or the complexity of L2 and L3s are getting you down, just head over to Supra. They'll get you sorted. Thank me later. All right, everyone, this is a message for my DGen listeners out there. If you are getting scalped paying expensive fees to perp dexes, I highly recommend that you check out Index Co-op's new leverage suite. Now, whenever it comes to leverage, do your own research. This is not financial advice. Don't bet more than you can lose, all that good stuff. But if you are going to lever up, you might as well not pay an arm and a leg for it. You can get leverage on BTC and ETH with built-in liquidation perfection, now available on Base, Mainnet, and Arbitrum. So click the link in the bottom of the show notes and head over and check them out today, and you'll hear more from them later in the program. Hey everyone, this episode is brought to you by Fuel Labs, who's launching Fuel Ignition, a new high-performance Ethereum L2 powered by the Fuel VM. Now you're going to be hearing all about Ignition later in the program, but for now, what you need to know is they are launching phase 2 of their points program. So click the link at the bottom of the show notes and head over, start experimenting, messing around on Fuel today. Thank me later.
All right, everyone. Welcome back to another episode of Bell Curve. Before we jump in, quick disclaimer. The views expressed by my co-host today are their personal views, and they do not represent the views of any organization with which the co-hosts are associated with. Nothing in the episode is construed or relied upon as financial, technical, tax, legal, or other advice. You know the deal. Now, let's jump into the episode.
All right, everyone. Welcome back to another episode of Bell Curve. This is a special episode. You guys will see why in about 30 seconds. But today I'm joined by my occasional co-host, Myles, and Ole from Delta. Guys, welcome to the program.
Thank you, Mike. Yeah, very excited to be on. I feel like this has been in the works for a little bit, so we'll be good.
Yeah, and excited to be on as both like a guest and maybe a co-host, kind of a hybrid here. And yeah, I think I've been wanting to talk about this on the pod for a long time, but I joined Delta as head of product in June, and yeah, just couldn't be more excited to share a little bit more about it today. I think it connects a lot of the episodes that we have been talking about and themes that we've been discussing on Bell Curve for years now. So yeah, this is an exciting episode for me.
Yeah, I'm pumped. This has been a little secret we've been gatekeeping here. And as we've been talking about, hey, if you could build an L1 from scratch, what would it look like? Well, what we didn't 100% share with the audience is that you are helping Ole do just that at Delta. And exactly. As a disclaimer here at the top of the episode, I am a small but proud bag holder in Delta as well. So just keep that in mind. Guys, we have a really exciting agenda planned for everyone today. So to give you all a little bit of a sense of the flow, we want to start actually before we get into some of the more technical weeds of Delta. We want to just give a little bit of a history around Ole and Myles. What did you see in the industry other blockchains were doing, and how did some of the good stuff and also the not so good stuff inform the design decision and the architecture of Delta? We'll get into some of the technical innovations that Delta has made, which is super exciting. And actually, Delta's kind of square in the middle of many of the most interesting technical discussions that are going on today. And then I've got a couple mystery questions or rapid fire questions for the two of you, what it's like to build a new L1, which we have not prepped for. So that'll be fun to go through live. But before we get into that flow, I actually, I think the mark of a really great founder is a unique insight, right? Like something that you believe very deeply that the rest of the market hasn't yet realized. And I think, underneath the entire architecture of Delta, there there is this insight from your perspective, Ole. So can I give it to you? And like, what's the kind of unique lens that you see the world through that might not be obvious to others yet?
Yeah, so we have thought a lot in designing Delta about essentially you're building a heterogeneous system from the ground up. Which properties need to be global, as in shared by, all the execution environments, and which are better left to these ideally very opinionated, more local execution environments. So this local global, dichotomy is very core to how we design the system, how we think about the world. I think related to that, and maybe also a unique insight, we have very strong opinions about decentralization and centralization in the sense that certain properties, really permissionlessness and openness, and in particular censorship resistance, you really can only get via decentralization. But on the other hand, if you want opinionated execution environments, this is the same as not having a neutral execution environment. And there we want our system to essentially be optimized for centralized, opinionated applications and the like.
No, yeah, I can chime in here too. I think maybe just taking a step back and looking at the crypto ecosystem broadly, there are two general approaches to building these networks, and I think one of them is what we see on Solana, Sui, Monad, and even rollups like MegaETH, where you are just basically optimizing one shared base layer, right, to support as much direct execution activity as possible. And I think that, this is very good for some things, right? You get a lot of things out of the box. You get all this shared infrastructure, you get shared assets, shared users, right? So this is a huge sort of boon to distribution early on, as well as, I think just being able to get something lightweight out there. But at a certain point, in every ecosystem, we see a new trade-off emerge, right? Where apps want more control. They want to own the whole user experience. They want to customize the execution environment for their application. And at this point, they face a trade-off between getting this control by owning their own execution environment, whether that's an app chain or a roll-up, right? And all of these nice benefits that you get when you share global state, right? And this really goes to distribution. And so these new apps, right? This is not a great path for them. They need distribution. They need shared infrastructure. And so, I joined Delta because I think it is the first system I've seen that can really break this trade-off by rebuilding the base layer from the ground up, right, to get the best of both worlds, where assets and users and all infrastructure integrations basically happen. They all live on one shared base layer, but programmability, right? The way to actually access applications, access these assets on the base layer, these happen in highly opinionated, dedicated execution environments. So I'll pause there, but that is just generally how I see, Delta fitting into the space, is saying, okay, well, if you're not going to pack all the activity in one place, like some of these systems like Solana, right? Here's how we would rebuild, a base layer that is fully optimized to support this sort of horizontal scaling roadmap.
So here, I want to try to draw out a couple of takeaways for the audience. And I think there were two basically that Ole and Myles, both of you just covered, which is one, thinking about things from a global versus local perspective. And we're going to get into how the architecture of Delta actually allows you to lean into sort of centralization as a governance structure for applications. And for old listeners of Bell Curve, we actually did a whole season on governance where we talked about something called like product governance fit, where I think we, over the years as an industry, are guilty sometimes of looking at early innovations like Bitcoin and then just trying to copy that level of decentralization around Bitcoin's governance to everything, including multiple layers of the stack for applications. But I think there's pretty good evidence at this point that that's not the right governance structure for like a gaming app or something like that. It just doesn't need to be that decentralized. But we still want these nice properties that the base layer, which is extremely decentralized, affords us. I think that is a really cool trade-off that Delta breaks. The other one is, Myles, what you were describing is, if you were to look out at the universe of blockchains today, what a monolithic blockchain like Solana gets you is everyone's on the same layer, and you get distribution, right? Which is like a powerful selling point for why many new apps are launching on Solana. The challenging part about that is that you don't have a lot of the customizability that you get from, say, an app chain, but in an app chain, you're on your own and you got to figure out distribution and build all this stuff yourself. And so that's another trade-off that Delta breaks. And again, we'll get into how, but is that a pretty fair summary of, what we've covered so far?
Yeah, I think so. I think in this sort of, category of systems where, they're trying to enable like more control to the developers by giving them their own execution environments, right? So these are like ecosystems like the ETH rollup ecosystem broadly, right? Celestia, even on Solana right now with network extensions. I think, what is the base layer's job? The base layer's job, table stakes is to provide really strong censorship resistant properties, right? To be able to support, to have enough throughput to be able to support all this execution activity happening at a higher layer. Those are table stakes. I think where L1s in this category actually will compete and differentiate is around the network effects, right? The positive network effects that they enable for these apps on top, and for these execution environments on top. And so I think this comes down to the properties you get in this shared settlement and, from an interop perspective, right? And so I think what Delta is going to introduce is, for the first time, in my opinion, like really positive shared network effects across every sort of, roll up on top, right? So when a user joins the Delta network for one app, that user is now part of a global state that is shared by all apps, versus with rollups where they kind of live in their own islands, right? Or if an asset issuer like an RWA, a stable coin, or a bridge deploys integrates with Delta at the base layer, maybe they're coming for just one app that they want to service, but now all apps on Delta have equal access basically to that integration. This goes for all of the, like block explorers, data providers, and all of the little things, right, that we are hearing right now are just, too costly basically for a new app to start off as an app chain. And so what I do hope Delta can really do someday is break this reality of like app chain, like basically apps that need to graduate to an app chain, right? It's only at a certain point where they can become an app chain because they have the leverage to do so and the resources to do so. We don't think that should be like the only sort of scenario where an app chain makes sense.
To summarize some of Myles' points, I mean, this really comes down to what are the properties and features that should be global and what should be local. So we talk about shared state. It's crucial to us that within the whole ecosystem, accounts belong to a shared state. We don't want bridges. We don't want third-party interop. The global state is really the gold standard for all of this. So that has to unite all of it. And that includes assets. You don't want to have to issue, a new USDC for each, what we call domains, the rollups.
Yeah.
It holds for the users, obviously. And then, the domains are also tied together in such a way that they can interoperate, again, without relying on third parties. They can have, even atomic composability, because everything takes place within a shared state machine. And then on the other hand, everything tied to execution is local. We only have sort of a set of shared, we call them global laws. If we think of this as a kind of, federated state, it's like the constitution, a very minimal set of global laws that all execution environments, all domains need to follow. And then beyond that, they are basically free and flexible to define highly customized, highly opinionated local execution environments.
Yeah. All right. So now we've described a little bit for the audience around why this is attractive, right? Because there is this challenge of you've seen this many different times in crypto play out where a product will start off as a smart contract, and then for reasons X, Y, and Z, Unichain is a pretty good example of this, right? They sort of graduate into an app chain. Maybe it's once they've got a strong enough brand or audience or users, and a couple of things might happen, right? One, for something like Unichain, I'm assuming it's just gas costs, right? Unichain has always been super. Uniswap has always been very concerned about MEV leakage through a whole bunch of areas, but just like gas in general is very prohibitive. So maybe there's a challenge with the common execution environment on, one layer like Ethereum. Maybe they just want to own more of the economics through things like MEV taxes, whatever it is. We've seen this, and these base layers act as like a launch pad. And again, Delta kind of breaks that trade-off by allowing you to be very opinionated about the execution, but still providing benefits to the essentially like the apps in your ecosystem through their own chain. So we've kind of described some of the benefits. Ole, can I call on you? Could you just give us like a description of, now the audience is prime for it, of what Delta actually is as a protocol, and then we can start to cover some of the very cool technical innovations that you guys have pushed that allow us to make this possible.
Sure. So there are two components. Again, we can think of this in terms of local and global, execution layer and base layer, if you will. The base layer consists of a decentralized set of validators, permissionless, vanilla in some way. They focus on disseminating essentially the transactions that come in from these domains from the execution layer, disseminate them around, are responsible for settlement, which takes place directly via snarks. The base layer is essentially also where, as we hinted at, all of state is connected, meaning all the users, all the assets, and all sort of metadata about domains. And then moving up one layer, we get to the domains, which again, they're kind of like rollups, but the very important difference is they're not independent state machines. Like rollups, in a way, in spite of sort of marketing to hint otherwise, are just like independent blockchains. Domains are not that. They are essentially like, again, like membership states in a federation or something like that, where they tie into the global state as a whole. And they take in user transactions, they execute them, they compute snarks, and settle it down to the global base layer.
Yeah, I think one analogy, maybe just to use like relational terms for the audience, is if you were to imagine Ethereum had a system where your assets never left Ethereum L1, they stayed on the base layer, right? But they could be reflected and used in much more scalable, right, highly opinionated rollups. And this would also require Ethereum to have some sort of new account model, right, where you would have a sub account that you would have your assets in for use in each rollup, just to avoid conflicts between them. But what this means is that, again, going back to what I was saying earlier, everything, all integrations, all assets, all users live within one shared state, right? And so there's no concept of having to bridge up to a rollup to go do something, or bridge back down and then across and then up to another rollup, right? So hopefully that helps the audience just kind of visualize what exactly we're talking about.
That is a very good example, because that single shared state is the common shelling point of chains like Solana today, right? And there's this perception out there that it's a trade-off. If you want that single shared state, everyone needs to be on the same layer, but that's actually not the case with Delta. So that actually introduces us to kind of the first of these very interesting technical decisions or architectural decisions that Delta has made, which is the state model. So can you, maybe Ole, I can call on you here. Can you just give a description of what is the state model for folks who might not be as in the weeds as you? And then what is it about the way that the state model for Delta works that enables you to do what Myles just described, with having basically an account on Ethereum be reflected in rollups?
A state model is, first of all, accounts. Everyone is probably familiar with that. Now, the important thing is we have these domains. Now, state is somewhat tied to them, but it is global, meaning as a user, you can only spend through a given domain at a given point in time. But you can, send, or as a domain, you can interoperate with every other domain because these still live within the same global state machine. So there's essentially there's a general asymmetry between spending and receiving, crediting and debiting. There are some pretty cool works on this that actually date back to 2019 that show that utilizing this essential asymmetry, you can build these state models that allow for local customizability at the same time as you have the global shared state and all the interop and all the distribution benefits you get from that.
Maybe I'll just add that, I think all of these benefits are not like lost on Ethereum rollups, right? Like they are seeing these same problems, right? And going after these problems. But Ethereum's base layer is, it's very hard to change, right? You don't see them making huge changes to do something like this. And so what you end up seeing is these clusters of rollups that are emerging that are trying to basically retrofit these benefits with on top of Ethereum. And frankly, we can kind of see just how complex all these solutions are that they need to implement to do so. And I think just bigger picture, it's much more powerful for this to be coming from the base layer rather than having all of these network effects sort of limited to these clusters, right? And as a developer, to get these things, you have to choose a cluster and you have to be kind of locked into that cluster, right? Either conform by their standards, whether that's the law of chains or a proving system or some sort of execution environment, limitation. And so I think when we say like, Delta is how we would rebuild Ethereum, or another base layer from the ground up to support this future with everything we know now. I think that's what we're really talking about. It's purpose built to support this future.
So one interesting consequence of this, I think, that might not be super intuitive is that, my understanding of this is that you no longer, in a system like Delta, you no longer require bridges, actually. And when you really get down to like what is a rollup on Ethereum, a lot of why it's taken longer than people might have thought to graduate some of these rollups to stage 2 is there's the settlement bridge and then there's the fault proof system or validity proof system or whatever. And Delta is like part of the state model that we're describing here that obsoletes that a little bit. I know we're getting into the ZK settlement part of this as well, but I mean, could you just describe that'll be, not super intuitive for folks. So you just, sort of underline why we no longer need bridges really in this ecosystem.
So, I mean, first of all, the domains obviously all share state, but the core thing here is they also share state with the base layer. So with Ethereum, the bridges are connecting rollups to Ethereum L1. I think honestly, there's been a lot of like deceptive marketing around like, oh, this is just the extension of a singular system. But in practice, you have smart contracts and you have bridges. In Delta, this is not the case because everything is part of the same global state. And in practice, when we talk about VK settlement, you are, as a domain, you're proving that, you've executed some transactions and they satisfy this list of global laws, the constitution, if you will. Now, how you settle it is you basically send this proof directly to the validators. Again, you know them, they know you, all part of the same state. And then they, verify this directly. You don't have to go through a smart contract. There's no bridge. Everything is integrated. Single integrated system.
Beautiful. Very cool, man. All right, I wanna actually move on here to another very interesting innovation that Delta is pushing forward, which is consensusless protocol. So on the base layer, Delta doesn't actually necessarily come to consensus. So Ole, how does that work, man? I thought that was the whole point of blockchains.
Yeah. I saw some controversy last week with a lot of people being like, this is consensus. Like, ordering is not everything that makes consensus. Academically speaking, consensus is atomic broadcast, total order broadcast. Now, the point is going back to this asymmetry between spending and receiving. There are, again, actually some papers from like 2018, 2019, which show that you can build some very simple cryptocurrencies which do not require enforced ordering by a validator set. So what you have instead is basically something called reliable broadcast, which is much less overhead. It requires much less coordination. I think an intuitive way to view this is if you need ordering, you need the sequential relationship between all transactions because, they have a position in a list relative to all others. If you don't need it, you can just kind of send transactions around in parallel. and you don't have this bottleneck. You don't have a leader dependency. The system is more robust, more lightweight, more efficient.
So how does I think this is going to challenge a lot of people's understanding of, they probably have this very Ethereum centric mental model for, all right, there's a bunch of transactions that get published to a public mempool, or more common these days, private order flow, right? But that all gets assembled into a block, right? Where a builder actually orders the transaction that gets, published through a relay and a proposer, which basically signs off on that and then disseminated. And then a bunch of other nodes, attest to the validity of that block. And what that's ensuring is strong settlement rights, although we don't come to finality immediately. And we should talk about how finality works in Delta and when transactions are ultimately final. But just help bridge the gap. Like with that, I think that everyone's kind of wrapped their mind around, okay, I understand that these transactions are final. They're ordered because all of these different nodes have signed off on it. So, my question to you is, how does that actually work in Delta? What are the assurances that, like, the settlement assurances and time to finality look like? And then I've got a couple questions for you on how censorship resistance works in this ecosystem.
Yeah. So tied to ordering, again, we come back to global versus local. Should ordering be a global property or a local property? Mike, if I send you a transaction, does really like the whole world need to participate in ordering this transaction? Or can we reduce this to, I'm in Zurich, my like Zurich domain orders it and then disseminates that ordered set down to the base layer. And this is how we approach it. We think that ordering should be a local property. If there are two domains that are, composing, there's some atomic composability between them, well, then they should coordinate and they should organize ordering between them. But there's no reason for like the entire global state, all the validators, to participate in this ordering exercise. So the TLDR is having a state model as we do, which has like this asymmetry between crediting and debiting, allows us to just have the domains ordered locally. And then when the results of those ordered lists are, submitted to the global base layer, they do not need further ordering to reach a deterministic output or result.
Yep. And I mean, Mike, you started off by describing basically the transaction lifecycle on Ethereum L1, right? And I think the complexity and I guess the maybe the tax, right, that inevitably comes out of apps at the end of the day, from the fact that the base layer validators are in charge of ordering the transactions for those applications. Like, that is a very serious tax that you have to incur for all the benefits of sharing state, right? And so again, that's another trade-off where I think we focused so far on the trade-offs that we try to break for roll-ups and app chains so far. But I think that that's a trade-off that we would break for apps on big shared state platforms right now, right? Once you kind of remove all these like conflicts in the state model, you don't need total ordering on the base layer, and the validators are just like less intrusive maybe to the apps and the execution layer, if that makes sense.
Yeah, this is why I just love that. I've always pushed back on there being one blockchain to rule them all, because different teams have such different approaches to solving these problems, and it's really cool. Like, I think one of the challenges that we're realizing from a scaling perspective on Ethereum, there's this whole debate going on: should we make the L1 great again or scale L2s? And I think the side that I come down on is you need to actually scale the L1 in order to scale L2s, right? Like a big challenge with interop on L2s is, when do you come to finality? Because very different system. Again, there's a bunch of transactions that happen on an L2. They get batched together. They settle back down to Ethereum. There's 12-second block times, but I forget. There's something like 15 minutes or something like. There's an epoch before you actually get to finality on Ethereum. And unless those transactions have actually finalized, you're taking risk, right? Anyone that's enabling opportunity up at the, or interop at the L2 layer. And so Solana's solution to this is basically make the L1 go very fast, right? And so we don't have to wait that long for finality. And this is another solution, which is we just rely on that like more local ordering and then just submit state diff lists back down to the base layer. Just final question for you here is, one, when should transactions be considered final? when they're made on a domain? Like, when does finality happen, this concept of finality? And then how do we ensure that if the domain is doing all of this ordering locally, that they aren't misbehaving?
Sure. So I'll answer the second question first. So basically the flow here is the following. The domain executes some list of transactions. It already has ordered the list, then executes it, computes a list of state diffs. After that, computes a proof that the list of state diffs is, a valid output or corresponds to a valid ordered list of transactions. So this is how they cannot cheat. What was the other question? Settlement? Yeah. Okay. So a transaction is considered settled when the state diff list that contained it has a proof that has been verified on the base layer. So we haven't yet decided if we're going to do this synchronously or asynchronously. Like, either you can submit the SDL first, then you submit the proof, and then it's final. I tweeted the other day that because proving is becoming so fast, I think we can kind of assume real-time proving. And if there's like a latency of a couple seconds, it's cool, it's okay. And then it's settled immediately when it reaches the base layer.
Hey everyone, this episode is brought to you by Supra, the new blazing fast, vertically integrated L1, which helps you scale your dApp. If you are a builder, you're probably dealing with some combination of cost, complexity, and fragmentation of existing solutions. So if you're building over an ETH L2 land, everything's feeling a little bit fragmented at the moment. And if you're building in Solana, everything is fast and on one layer, but maybe you're limited in terms of what you can do with your AppSpace. So Supra is rolling out a new product called Supra Containers. So you can head over to supra.com/containers. To learn more. They offer dedicated customizable app spaces running on Supra's 500,000 TPS Layer 1 blockchain. That gives you complete control over gas tokens and fees. So some cool things you can do. You get the freedom you can use your own token, create local fee markets, or even go gasless, whatever you want. So this product isn't live yet, but because you are a faithful listener of Bell Curve, you get notified first. So head over to supra.com/containers. Thank me later. Hey everyone, this episode is brought to you by Index Co-op and their new product, the Leverage Suite, which I highly recommend that you check out. Click the link in the bottom of the show notes. Now, disclaimer, whenever it comes to leverage, do your own research. This is not financial advice, all of that good stuff. Don't bet more than you can lose. But if you are going to lever up, you might as well not pay an arm and a leg and save a ton of money and use Index Co-op's Leverage Suite. So the way that they actually achieve these savings is pretty cool. They leverage the power of money Legos, DeFi, in this case, Uniswap and Aave. So the cost of carry for this trade is actually based on the funding rate of Aave as opposed to perp dexes, which tend to be much more variable and higher overall. Additionally, perp dexes will also charge you usually based on the entire open interest, so the leverage exposure that you have as opposed to just the amount of money that you put in, which is what Index Co-op is doing here. And the result of what you get is just an ERC20, which gives you something like 2x ETH. So if you want to lever up and you want to save money doing it, I highly recommend that you go check out the Index Co-op Leverage Suite. Very, very cool. Thank you very much, Index Co-op, for making this episode possible. Hey everyone, this episode is brought to you by Fuel Labs, who's unveiling their new high-performance Ethereum L2 Fuel Ignition. Many of you know Fuel as the launcher of the first optimistic Stage 2 rollup on Ethereum with Fuel V1, and now they're launching Ignition to address some of the creeping centralization concerns around some L2 architectures today. And if you like nerding out about the tech, there's a lot of reasons to get excited about Ignition, including how they solve state sustainability and performance execution. They have this UTXO asset-centric architecture that's very, very cool, but there's a lot of other reasons to love it. Super easy to use. You can either use a Fuelet wallet or your existing Ethereum or Solana-based wallet like Phantom or MetaMask or whatever it is. There are cool apps that you can experiment with. And again, like I said at the top of the program, they're launching phase 2 of their points program. So click the link at the bottom of the show notes, head over, start having fun on Fuel Ignition today, and just tell them that I sent you. So that gets us into the sort of final technical innovation I think that Delta has leaned into, which is ZK settlement in general. We've been referring to these things SDLs, State Diff Lists. So can you just define, when we're talking about ZK settlement, what does that mean? And then I realize that we haven't defined State Diff Lists yet, so maybe give us a quick definition for that as well.
Yeah. Okay, let me do that first. So you are executing a list of transactions. Now, that can be like, me sending Mike some money, Miles sending me some money. So we have very simplified, like pluses and minuses for all the accounts are the output of that list of transactions. And we, instead of publishing the list of transactions to the L1, we just publish this list of state diffs, which are like, Mike has, 5 more coins, I have like 4 less coins, and so on. So that's a state diff list. It's again, talking about local and global, this is a standardized format that all the domains have to comply with. So, they're submitting state diff lists and they get applied to state. The other question, what is ZK settlement? So we think of this within the context of a shared state machine. So this, by the way, means that, roll-up settlement is not ZK settlement. The point is, how can you achieve heterogeneity within a shared state machine? Because usually what you do is, all the nodes in the blockchain re-execute. They have the same, the same execution model, the same VM, whatever. They have to re-execute all the transactions. In Delta's case, they do not. You can have domains live within the same shared state machine, but they still, have one has EVM, one has like MoveVM, one runs JavaScript or whatever, and then they all prove one sort of fixed part, which is what we call the global laws, again, the constitution. And then they have one more variable part where they can choose whether or not to prove, the full execution, and that will be a more local verifier that they have attached to their part of state.
Exactly. And I think that's a really big point to make. The fact that they're not proving they're not required to prove full execution path, right? So that enables, a domain or our version of a rollup, right, to be something as lightweight as just a simple cloud function, and submitting, basically the very minimal proofs of the very minimal global laws that you adhere to for any activity happening on that domain. That's on one end of the spectrum. On the other end of the spectrum, you can have a fully trustless rollup that decides, right, I want to actually prove the full execution path because that's what I think my customers want, right? And that's what I think I need to facilitate high value DeFi activity or something like that. And the fact that they can use any VM, right, is just another sort of like axis of competition. And the fact that these can all live together within the same shared state, right, that's really the first time that we've been able to do that.
It's super cool. The ZK is as a big unlock, I think, for that word heterogeneity that you used, Ole, because I think what we're seeing is trying to jam anyone into, like, the EVM. We've known there have been problems with for a long time, right? Just in the way that it's constructed, it doesn't enable parallelization, all that kind of thing. And then there's the SVM, right? And the SVM, it does some of this stuff. You've got account lists and things like that, so you can parallelize transactions, and it goes a lot faster. But there are still issues with that, right? It feels obvious to me that applications are going to want their own execution environments. That's like largely how it's evolved in, Web 2 for the most part. And so being able to get knitting all of these things together, enabling that heterogeneity, and leaning into local actions around things like ordering, that type of stuff, while maintaining the benefits of a common state model is huge. And just to zoom out of some of the technical speak, the way that I think about this is, it's kind of this question of what services should the base layer provide to the domain or roll-up layer, right, to the applications. What services do you want to ultimately provide? And I think that the services that Ethereum provides to roll-ups today is basically the settlement assurances, right? That's what they're trying to optimize for. But there's more that the base layer can actually do. Like interop is probably the biggest one here, but I don't know if there are other benefits that you see Delta providing to its domains. And then I want to ask you guys about some of the drawbacks or trade-offs. Like, we're talking about this very positively, like, what are all these great things that Delta does? What are some of the trade-offs that you've made as well?
I think that a core trade-off relative to rollups is, because you are part of a shared state machine, you cannot easily social fork. Like, you're not running your own, your own thing. So you cannot just be like, hey, no, actually, I disagree with this. I'm gonna, reinstantiate my state in this way. So you definitely lose some of, I don't like the word sovereignty, but what people refer to as sovereignty in that sense. I would say that is an important trade-off. And then I do also want to say that so domains can have atomic composability across each other, but this is not something we're optimizing for. I mean, we think that the vast majority of atomic composability will be within each domain. And although you can do it across domains, this is less scalable. Like, you need something that looks a lot like a shared sequencer, or like those domains need to collaborate or coordinate in some way. So I would say that is a trade-off that we're making relative to a Solana or a Sui or a Mega ETH or whatever have you.
So that local, like, we do expect, and like I hope to see some basically local, like, opting in to coordinate with other domains that they frequently interop with, and they share a lot of users, right? But I think we want to make that opt-in, and we want the base layer to be not incredibly opinionated about that, because we do really like the trade-offs that you get from basically this level of opinionation.
Yeah. What about, I saw, Ole, you were going back and forth with M-Team is loading on Twitter about like this concept of real-time censorship resistance. So can you talk about the censorship resistance guarantees that you get in Delta versus something like Ethereum?
Yeah, thank you. That is another trade-off that we're making. Again, we want the domains, the execution environments, to be extremely opinionated. We're talking to the point of like, run your own private server and let that be it. We're all for centralization on that layer. So we're not gonna demand of them that they provide real-time censorship resistance or censorship resistance at all. We don't think that censorship resistance should be a local property. It should be something that you get globally within the system as a whole. But if I'm running a business, it should be fine for me to just be like, no, I'm running an application, it's no go unless you do KYC or something. That is totally fine. The point is, globally, you need to have censorship resistance. And again, this is provided by having a globally shared state layer, so that you can talk to validators directly and be like, hey, I'm being censored here. Can I go over here? And then you just tell them, they know who you are. There's very little friction here. And then you just move. So there you get censorship resistance. But this is not real time. So that's another trade-off against, like, I don't know, Max Resnick's vision and stuff like that.
Sure. But it is pretty elegant that you can take, basically lift and shift your account and all the assets in it, right, over to another domain. And it's not like the assets that you're taking with you are specific to like the domain you're being censored on, right? It's not like you have USDC that's like this rollups version, right? These assets that you're taking with you are global and just as useful elsewhere. But yeah, I think
importantly, they're not bridged. There's one asset implementation across the entire thing. So you're just taking your USDC, and as Myles said, these are fungible across domains. These are the same USDCs. So yeah, I mean, it's pretty simple. It's pretty basic.
Yeah. And it's interesting. You kind of eliminate the concept of wrapped assets. And for what it's worth, I think this is going to happen across all these other chains. It's just slightly different in that I feel like the Ethereum approach to this, even though it hasn't necessarily been spelled out like this, is that, when you bridge your Ethereum or any assets from the L1 up to a layer 2 like Optimism or Arbitrum, you now have a wrapped version of the asset. Now it goes through an extremely secure bridge, right? So even though it's wrapped, the security assumptions of that bridge are very strong, and so we just kind of call it ETH when it's on Arbitrum, even though we know it's wrapped ETH is the idea. So,
of course, I mean, for assets issued on Optimism or Arbitrum, you cannot derive the same guarantees from the base layer. So this is another distinction here, that because all the assets are actually tied to the base layer, you get these like L1 direct guarantees really by default.
yeah, I've wondered that for a while now, how this is going to end up working out I know this isn't but I'm just curious about this, like, because you do have now, there's a bunch of ETH that's been issued natively on Arbitrum versus ETH that's been bridged over. And in the case, you listed one of the drawbacks of Delta's design as being, you lose a little bit of that sovereignty around the ability to fork. But it would be, I mean, knock on wood, I actually hope this doesn't happen, but it would be interesting to see how a roll up would treat, some mass hack or something like that, and they actually had to fork, right? They have, control over they've got the fork choice rule, but yeah, you would, anything that's been issued natively, you're pretty good on, but bridged over is trickier. So that's maybe just a thorny problem for all chains in general.
Yeah, right. And I think, the trade-off around not being able to socially fork, I think we're fine with it, because I think it's addressing a bigger problem, which is the cold start problem, right? That AppChains have today. And so if you can never get to a point where you have assets, that you actually in a community, right, that you actually need to social fork, then it doesn't really matter. I think what's more important is solving for adoption, distribution, and awareness, right, with a large initial base or a shared base of users and assets.
I think this is a very important point. All of this is about trade-offs. So a way that I think about it is, okay, forcing domains to be part of global state is a trade-off in the sense that you cannot do social forking, but you can think of what does that enable you to do? Because you have conceded this trade-off, now you can, have all of these benefits in terms of distribution and interop that you wouldn't have if you, were so stubborn about running your own state machine.
Yeah. Okay, guys, I want to, anything else on the technical side here that we didn't cover that you want to have got? I'm going to put my founder hat on here and just ask you guys some questions about building Delta and some more strategic questions, but anything we haven't covered on the technical side?
Well, I do want to emphasize I think that consensuslessness, or whatever we want to call it, is a very big deal. I think that we're going to see a lot of systems that do this. Something we haven't really touched on is that Delta can scale fully horizontally. It can scale, execution, that's not so interesting. You can add more domains. Okay. But in this case, because you have this leaderless, parallelizable consensus, or consensusless, whatever you want to call it, right? Which doesn't have the linearizing bottleneck of the blocks. You can run mempools in parallel. Validators can add machine. They can kind of arbitrarily add bandwidth in a way that you cannot if you have traditional consensus. It's just impossible. So I think that this is a very big deal. It makes for more robust, more decentralized, because you don't have a leader dependency. So a more decentralized, base layer protocol, more lightweight and parallelizable. I think it's a huge deal. I really think we're going to see many projects that utilize this.
Oh, one thing that I didn't ask you, but I'm curious to get your take on, is that Delta's extremely unique. It was one of the reasons I was so interested in it in the first place. But a lot of what you're describing rhymes with other technical conversations that are happening in the world of crypto. So even like leaderless consensus, right? That sounds a little DAG-ish to me, right? That sounds a little kind of like a DAG. And even it also rhymes a little bit. It's sort of related to this, now new, very exciting topic of, multiple concentric proposers, right? MCP. And then I hate this acronym. I'm changing it. It is ACE.
There we go.
It's the idea of applications being able to order their own transactions. So where, how and where do you see some of the innovations that Delta is making fit into some of these other conversations?
Yeah. I think it's interesting. For all of these, I think that you start off with a high-level concept and a word, and it sounds the same, and then you dig in, and with DAG-based consensus, you actually need ordering at the end of it. There's a lot of marketing where people will be like, "Ooh, seamless interoperability," and then it's just like, "Hey, we have enshrines and bridges,"
Right.
But yeah, MCP is very interesting. I think that the things that they are trying to achieve are basically real-time censorship resistance. Whereas for Delta, we have something like MCP because you have the domains kind of act like what do you call it? Yeah, composers? No. Whatever. Proposers. There we go. I knew there was something off. And then they are like just concurrently producing. They're just like streaming transactions. It's very different. It's a very different goal. And application-specific sequencing, I don't know enough about it, but it's roughly, you can run a domain. One of the many things you can do is to do your own ordering. You can do your own sequencing. I think application-specific sequencing, promises something similar for applications on call it monolithic execution environments, but I'm less familiar with that.
All right. I want to ask you guys some questions about just what it's like to build a new L1 today. So, I'm very curious. The way that I would look at this is just kind of classic. There's incumbent versus startup, right? And what are the pros and cons of building each? And when I look at the incumbents, which you could kind of put that in the bucket of Ethereum or Solana or Celestia or even Bitcoin, I suppose, depending on how you define your competition. What they have is network effects, and there's network effects of around the actual asset, but then also in terms of developer community and that sort of thing. But on the flip side, what you have with Delta is you have none of the tech debt that or any of the mistakes, right, that protocols like Solana or Ethereum have made in the past. And you get this sort of second mover advantage where you can look at all of these clever innovations that all the different ecosystems have made and compile it together in one very interesting, potentially better solution from a technological standpoint. And you're smaller and nimbler and all that kind of stuff, but you're still competing against these incumbents. So can you just, walk me through, how you just view building an L1 today in general?
Yeah. Okay, so I don't want to be like we're just growing the pie, like we're not actually competing. But I do think that we are.
Thank you,
We're
Ole.
thinking,
Thank you.
I'm not going to do that. Like, yes, we are. We're definitely competing against the rollup vision. Are we competing against Solana? I think these can coexist. But we are also thinking about, say, use cases and application spaces as a whole, which are not the same as what these ecosystems are focused on today. And we think we can uniquely enable some things that others cannot. So that's more of doing something different versus directly competing. Now, I don't want to sidestep the question. I think that you've addressed very well, okay, we have better tech, but also the network literally doesn't exist. You have these things that have a bunch of developers and a cult and all that. I mean, it's a meaningful challenge. What I think about Delta when it comes to network effects is, let me see if I can make this not overly technical, but you have it's quadratic, right? So it's n squared, but there's a factor in front of the n squared. And this is actually not a constant. So it depends on the infrastructure. So what I mean by this is this factor for Ethereum rollup space is a very small number because they're essentially just independent blockchains. And the shared network effects you get just by being a rollup on Ethereum are quite minimal. They're not great. So by being on a domain on Delta, you just automatically, even if there's little happening, which, in the beginning, there will relatively be little happening there, the shared benefits you get from being sort of in that global state thing will be very significant, comparably.
Yeah. I would just add that, we have, I don't know if we would call it a third or fourth mover advantages. Maybe it's definitely not second mover advantages here. And it allows us to build a system that is, I think, going to be the most aligned to the interests and demands of our demand side of rollups or domains, right? I think we see tension in every other ecosystem that, has come before us because they weren't built right from the ground up with this information. So you have a tension between, L1 activity and L2 activity and value capture on Ethereum broadly. You have a tension between, let's say control Solana developers that want more control, right? These network extensions and really the roadmap of Solana L1. And I think we will see more tension between, base layers, even Celestia trying to pull settlement back in, right, against these clusters, settlement clusters that have been built on top at some point. And so we take all of this into, account in building Delta to be the most aligned with what we know the demand side wants. And we want to make the base layer as minimal as possible, but also basically just take away as many pain points as possible for the demand side of domains, right? And give them these things out of the box that the L1 we think should provide. And over time, I think, this idea of like graduating to your own chain should go away, right? If the costs of doing so are not really worth all those benefits anymore. So I think we can talk about specific use cases as well. But in general, that's how I'm viewing, our positioning here.
So I got a follow-up question for you guys. And Myles, this is something you and I have talked about quite a bit, but how do you think about value accrual for the token? And this is a catch-22. This is a Mike Ippolito opinion here, but the catch-22 that I see for a lot of L1s is that, on the one hand, what you don't want to do is be rent extractive, right? Like you're ultimately serving the end customer of the app devs. And yeah, the more extractive you are in terms of however you monetize or whatever type of rent you want to impose, the less likely they're going to want to be to build on your chain. On the other hand, I do think that we've seen that the market cap of the native token is kind of the market size for app developers that are building there. Like a huge advantage that Ethereum has over Solana today is they've got some $300 billion worth of crypto native capital versus Solana's 80. And so if you're a dev building in that ecosystem, it's just a lot more, it's easier to get liquidity, there are more users, etc. And so how do you think about balancing that in between? I got to extract a little bit here because I want to sell a compelling story and make the number go up and the token go up so that devs will want to build here versus, not wanting to be too extractive and, you could risk sort of cosmosification where, yeah, you get a bunch of app chains, but it's not clear that value accrues to the token.
I think that it's very, very difficult to balance these concerns. I think ultimately you want to be quite singular in your focus. For us, we just want to build the best tech. Our product, if we throw like a huge party to market the token, you'll know it's over. This is not really what we're in the business of. We care about like building an economic model of incentive mechanisms that make sense to, achieve the types of behaviors that we want. But no, we're not focused on like token go up stuff.
Yeah, I think maybe you could also say we're optimizing for value creation, right? That is the core focus here. We want to be the best place to build, highly opinionated applications, and we want to provide network effects that, make these applications want to stay on the platform, right? And I think the way I view the economics of Delta is kind of like a marketplace for finality, right? That's really all the base layer validators are doing. They're updating state. They're basically facilitating finality that enables interop between these domains, right? Mm-hmm. And I think an axis of competition between the domains is how often they do submit, right, state updates to the base layer. The more often they do, the easier it is for users of their domain to come in and out and move around. And so I think it's in the incentives of these domains, right, to be using the base layer quite often. And I think we'll see that play out pretty early, early on. And then I think there's another interesting dynamic about Delta that we haven't talked about here, where there are strong incentives for these domain operators to also act as validators, right? You could have basically the demand side operators also operating a significant portion of the supply side operators. That is the way that it's kind of new formed of like a based roll up, right? Where they are both like the proposer. They obviously cannot, they still have to submit proofs, right? They still have to disseminate information and get 2/3 of other validators to sign off on the State Diff Lists, right? But what's interesting about that is that it puts less pressure, right, on Delta token to incentivize that supply side, when the demand side is naturally incentivized to do that for the benefits of their own product, right? And so we may not need as much, like inflation and things like that. We may end up with something much more sustainable very early on. But are we thinking about like ways for the base layer and the token to play a role in MEV? Like, no. We want apps to control that. And we think that if you are able to, basically just optimize this marketplace for your demand side, grow the demand side, there's going to be plenty of ways to capture value later down the road. Like it's just shouldn't be a focus early on. I do understand that, there is this sort of, I don't know, thing in the back of my head and everybody's head for the market needs a narrative for the token that they can jump on. And I think, we kind of resist that a little bit.
I've got a question for you. Just, you brought up token supply. I'd be curious how you guys think about supply dynamics in general for tokens, because there are a couple of principles in around L1s I think kind of came from Bitcoin, which people really latch onto, right? There are a lot of supply side investment arguments that get made in crypto, I think. But, the reason people like Bitcoin's monetary policy is one, there are going to be 21 million coins until the heat death of the universe, no more, right? I mean, technically they could change it, but they probably won't. And then the other thing is it's very predictable, right? So I would actually argue that the predictability is the more important factor there than even the no more coins than 21 million until he does, because it introduces all these challenges around their security budget. Everyone kind of knows this already. But when you guys are thinking about the quote monetary policy of something like Delta, what appeals to you? Because there's the Ethereum ecosystem, which is there's the burn. And so it's a little bit more variable, but you wind up with, well, I mean, at least you used to wind up with like a net burn and a decrease in supply. Like, how do you guys think about supply dynamics of the token at all? Or is it not something you thought super deeply about or very concerned about?
Yeah, this should all really be about sufficiently incentivizing validators to want to validate. So I kind of think of this in terms of just like a regular market transaction. The fees for the SDLs will be based on making the validators just at about profitable, and then a small bonus of the leaderlessness thing is that you can submit directly to a validator and they will compete among each other. So essentially they will be like, hey, I will process your transaction at like this price, and the other will say, okay, I'll undercut them. So our goal is for there to be essentially just a market that determines what fees should be like, so that validators are just about profitable but not too profitable. That's really how I view it.
Yeah, I don't have a ton to add. I would just say, like, again, what should the role of a token be, right, in a marketplace that is trying to align itself with the demand side? And I think that means not imposing itself on end users, right? The token is needed for domain operators, sure, but it's not like end users need to be holding this token to onboard and do things on domains. And then the monetary policy just needs to result in something that is, sustainable enough that domains know these operators are going to keep, processing their transactions, updating the network, and they don't have to worry about it, right? That's largely how we're thinking about it, or at least I am.
I agree. I think it's also very cool, by the way, that there's a sort of a market-based mechanism for how much you should pay validators. This is the big question on Ethereum, and eventually it will be for Solana as well, right? But it's like this is the whole, minimum viable issuance debate or ETH issuance endgame debate that's happening around, hey, are we overpaying for security? And you kind of have to like lick your finger and put it up into the air. But if you have a market-based mechanism, it just allows you to be more precise relatively, right? Okay, I got, in sort of winding down list of questions for you guys, I want to talk about almost like the pomerium or the dividing line about services that you think about Delta offering versus what you want built by third parties. And so, what I mean by that is if you look at just infrastructure specifically, Ethereum has much more third-party infrastructure built than a chain like Solana. And Solana has, I don't even know if this is, it's an integrated chain, right? So they do, you have things like native stake delegation and stuff like that, which makes it the value proposition of liquid staking much less appealing, right? So consequently, you have Lido over in Ethereum land that has way more market penetration than even a great service like Jito. And so I would be curious from your guys' perspective, when you're looking at those two ecosystems, do you have strong thoughts about, kind of this market-based third-party infrastructure approach versus Delta doing more and maybe even launching first party like a Delta domain or something like that?
Yeah. So First of all, again, we get back to global and local. I mean, the
Mhm.
global should be really simple and really basic, and I think we should abstract away as much complexity as we can. Um, like Delta is an integrated network. We think that the integrated approach is the right one. Now, locally, you can think of this as kind of like the internet. You can do whatever you want. You can write your web app from scratch in Rust, but if you want, you can use WordPress or you can use like Wix or something like that. So we want to make sure that you can very, very easily, like trivially deploy your own domain. And we will probably build some of this infrastructure in-house or incubate it. But that's crucial to us that you can do that at the same time as, we want to maximize the optionality, meaning if you don't want to opt into that, you want to write your thing from scratch in Rust instead of just like dragging and dropping some components. You should also be, able to do that.
Yeah, I couldn't agree more. I think we're what we're talking about right now is more focused on, I think, like the development company, and products that they can be built for the benefits of the whole ecosystem, right, from our side. And I do think it comes down to developer onboarding and user onboarding. And so that's something like, an easy tool to deploy a domain, and it's something like maybe even like a first party like version of ENS and a first party wallet that just makes it really, really easy for crypto users and non-crypto users to start using an app as soon as possible.
Mm-hmm. Yeah, it's interesting. I think just this is where path dependence is just funny and difficult to measure, and there's sliding doors moments all over the history of crypto. But it's funny to watch something like Lido play out in Ethereum, where it was a very and it's still, I mean, it's an incredibly important protocol, very close to the metal. And you've watched the sentiment around Lido change a little bit over the years. I'd say this is a very pro Lido person. Blockworks is a delegate there, but and basically Myles and I did a whole season on this. But it was initially there was kind of this threat of Coinbase, and then Lido was a more decentralized solution, and then it's like, wait, looking pretty big these days, right? This is pretty core to how Ethereum works, and so yeah, it's just this is I think one of the advantages that Delta has as well, where you've just seen a lot of this play out, and it's an interesting trend I think in Ethereum and actually Solana as well, where you're starting to see app devs actually build out the infrastructure underneath them to support. We had Eugene on the program talking about Atlas, the new SVM L2 that settles down to ETH. I thought it was a cool example of that, where they took a lot of their lessons learned from building Phoenix, the Clob on Solana, and then implementing that into their environment. So
I agree that this is cool, but I hope that long term they won't have to. And this is, one of our goals is to
yeah,
make it easy enough to deploy a highly opinionated execution environment that you don't have to go that route. Like then,
yeah,
there you only have a finite amount of energy and focus. And the more that you spend on developing underlying infrastructure or, things like interoperability and distribution, the less you can really spend on, well, your product itself, getting people to use it and these things that really should be your core focus.
Right.
agreed.
And yeah, maybe I'd just add is like we do have the ability to look over and see like, hey, we don't really want this Lido situation to happen on Delta, but that doesn't mean that like, we should do a first party LST. Maybe we should think really deeply about a system where, an outcome like this just doesn't need to happen, right, at all. And so I think that's part of the, large part of why I joined. And it's been a lot of fun.
Hmm. Final question for you. Now to use this sort of simple analogy of the Constitution, right, of the United States, which is this very minimal set of rules that gets federally enforced and informs a lot of our law, like that. Let's just try to translate that to Delta and say, okay, it's a very minimal base layer, but it globally enforces these properties. How do you envision the decision-making process going for adding something, right? Like when the roll-up centric roadmap started for Ethereum, people were kind of concerned. I actually remember going to a ETH Denver conference a couple of years ago, and people were like, "Hey, has anyone thought about the interop? Probably like issues here." But anyway, obviously issues are going to come up. We add stuff to the U.S. Constitution; it just takes an enormous amount to do that. So, how do you think about the governance or like adding new parts to the Delta Constitution?
So everyone should read D Hawk, the founder of Visa. He was very much ahead of his time. The development of Visa, initially it was Bank of America, and they, franchised it to other banks, and it kind of sucked because,
Oh, no
Bank
way.
of America was in the middle and the banks didn't trust them. So, D Hawk was like, hey, we need an organization that is purely about Visa. And then what you get is this very interesting dynamic where all the players, all the banks simultaneously are competing, but they also have to collaborate, because if they don't collaborate in some way, the system doesn't work. We think about this in much the same way. I think it's a huge advantage that this is an integrated system. I mean, it's not just about the technical benefits. There is also I don't want to use the word alignment, but you know what I mean? Like, we are meaningfully in the same state machine doing the same thing. I feel like I'm sidestepping a little bit, like upgradability and stuff. I mean, hopefully we can add enough things prior to launch that we don't have to, worry too much about this. That would be my response. But I'm very scared of DAOs.
No, I know, and we don't have to bring DAOs into this. I think, Mike, you and I have talked a lot about, like, it doesn't always feel at the who has a seat at the table at these L1 like governance discussions, and it doesn't feel like each stakeholder group is evenly represented, right? And so part of that is because validators are the ones responsible for running, for deciding basically if these upgrades happen. And so another part of, like, why I'm excited about having a system where domains are naturally incentivized to run validators too, is because that starts to, okay, now we have like different stakeholder interests that are also running, validators, right? And it could be more balanced. It could be like, okay, you want to add these global laws. Some validators don't, but other validators can like say like, hey, no, this is going to be really good for the network. This is why we want to do this. And it's just more equal representation, I think, at that layer.
What percentage of domain operators do you see running their own validators as well? I think this is a very cool feature of Delta, and it's a point that Anatoly over in Solana has made that has resonated with me pretty deeply, which is, I think the conception of node operators, even in like Bitcoin and in Ethereum, is that they're their own stakeholder, right? They're their own separate class of people. And, Anatoly's position for a while has been, if Solana creates, a valuable enough shared state, businesses will be incentivized to run these validators. And I've been pretty convinced by that argument. I'm not gonna lie. I've let that marinate for a while, and it makes a ton of sense to me, actually. So you can think about operator profitability in a different way, if you accept that as an assumption. So what do you see? What's the Venn diagram in between validators and domain operators on Delta? You see, I know this is difficult to ask before the network is even live, but
I don't want to chuck out a number, but there is an additional benefit to doing this on Delta, which is you can essentially guarantee your own finality, because because you don't have block builders, there are no leaders. If you can trust the validator that you're submitting your SDL to, and if it's you, then you probably can, then you can guarantee that it makes its way through the rounds and actually, gets settled. So you have totally different settlement guarantees than you get when you have a leader-based consensus. So, based on this, I would imagine it's quite attractive to like really a lot of domains. Myles, what do you think?
No, I think it is. I go back and forth in my head because I know app developers don't like running infrastructure in the first place. And so I do think there will be a lot of app, domains that outsource this to, professional services, but they're running it for that domain, right? They're not just like outsourcing it, sending it to random validators. It's looks almost like part of, what I would expect a domain as a service business to include is, hey, yeah, we're going to run, the DevOps for your domain, but we're also going to give you like even better properties, right? Because we'll be running a validator that is, paying it, basically working directly with your domain.
And they would just say like, hey, low cost, guaranteed finality. Do you want this at like an extra fee of $5 a month or whatever?
Yeah, exactly,
Realistically,
exactly.
that's what it's going to look like.
Yeah.
Super cool. Really interesting opportunities for any operators that are out there listening. And there's a whole other podcast that we could do on settlement and finality. And we'll link it in the show notes, but friend of the pod, Crane, wrote a great post about this. Maybe that'll be bell curve round 2 with the two of you talking about that. But for now, you guys have been super generous with your time. And I really appreciate it, guys. Very excited about Delta in general. If folks want to find out more about the work that you guys are doing, what's the best way for people to do that?
Follow us on Twitter, delta.network, where we unfortunately have to write the dot because some dude claimed Delta Network in like 2011 and hasn't posted since. That's the best way. Find us there. We have written some things. We're going to write more things, put out more content. So stay tuned.
My heart goes out for the domain squatters. Actually, it's funny. We did so little in the beginning of Blockworks. We didn't actually do research that Blockworks actually exists. It's a Minecraft company that builds like fantastic new. It takes them like 6 years to build a new world. And I was kind of looking at like, I can't even be mad about that. Blockworks is a really good name for that company. That actually makes a lot more sense than our name. So yeah. But,
wait, so did the name basically trigger like the research? You were like, we need to,
Got it. I actually told this on stage a little while ago, but initially, I was a consultant before this, and initially the idea behind Blockworks was to create a, blockchain consulting company like 7 years ago. We were like, well, we don't have any brand, so we were going to host events until we could become consultants. And actually, we were originally Blockworks Advisors as the name. We used to be Blockworks Group. We dropped the group. But my old boss, now a good friend of mine, sponsored my first event when Blockworks was my side hustle nights and weekends job. And I panicked. I was like, shit, he's going to see the name advisor. He's going to think we're doing a consulting thing. We got to change it. And so we became group like the night before this event. And our legal name for the first, we incorporated as Blockworks Advisors. So if you dealt with us in a commercial capacity, you would have seen Blockworks Advisors on the list.
Well, you guys have come full circle now. You launched the advisory product.
Right.
So
yeah,
well done.
Circle.
Well done.
Yeah. Well, this isn't about me, but yeah, little Blockworks lore for anyone who's interested in that. And yeah, guys, really appreciate you. I'm sure this won't be the last time that you're on the pod. So yeah, we'll check back in and have to do this again sometime soon.
Awesome. Great. Thank you, Mike. This has been great.
Yeah. Thanks,
All
Mike.
right, guys.
Yep.
Cheers.
See ya.